Okay, so this is the notes for 7.3, part 2. So if you look at C, so look at this. You can try from now to the cows come home, and that is not going to factor, which is why I gave us a note here. We have to use our quadratic formula. So if I use my quadratic formula, and I'm going to kind of go up here and do it, it would be sine x is equal to -1 plus and minus the square root of 1 minus 4 times 2 times -2 all over 2 times a, which is 4. If you do the math in here, you're going to see that the discriminant underneath is 17. So when I did the math, I got -1. Oh, actually, it should be +1 because it's -b. Plus and minus the square root of 17 all over 4. So now, pop that into your calculator, and you should get, so if I did 1 plus root 17 over 4, and I got about 1.2808. And then I did 1 minus root 17 over 4, and I got -0.7808. So look what happens first of all to this one. If you pop this into your calculator by doing inverse sine, because remember we're looking for the angle, it's greater than 1. You're not going to get any solutions from that. Your calculator will give you an error. If you do the bottom one, so I'm going to do it for you. So look, you get inverse sine -0.7808. And I want you to look to see what happens. Now, because the sign is negative, your calculator only gives you that restricted domain one. So since the sign of the angle is negative, it's in the fourth quadrant. The problem is that is not between 0 and 2 pi. So what you're first going to do is you are going to add 2 pi to this, because that's going to give you your angle between 0 and 2 pi. That's negative. That's not between 0 and 2 pi. So I just added the 2 pi to get the angle that looks exactly like it. So the first answer would be x is equal to, we'll just go 5.38. Now, remember, let's think about this carefully. If I have sine being negative, sine is negative in the third quadrant and in the fourth quadrant. This is a fourth quadrant angle. It's a little bit less than 6.28. How do I get to this third quadrant angle? Well, this is going to be a little complicated. So my negative angle that I had was -0.8959. That's what that first one gave me. Okay? And this is what it looks like. So wouldn't the third quadrant angle be this angle right here? So what it would be is it would be pi, or 3.14, plus the 0.8959, because that's what this is right here. And if I do that, if I take pi, so let me clear this out. So if I just take pi, and if I add 0.8959, you're going to get 4.037. Let's just go 4.037. And if you do the math and change that into degrees, you will see that that is a third quadrant angle. So there are your two angle measures. That's a little confusing, but you kind of got to look at a picture. I think it helps. This angle is negative 0.8959. My third quadrant angle would be this angle right here, so I would have to take my original pi right here, and I would have to add that 0.8959. Okay, as if that wasn't fun enough, let's do D. So remember the tangent to theta we had at the beginning? We have this mess inside here. So, first of all, the sine part is already alone. So what they're really saying is what angle has a sine of 1? So we'll do 3 theta plus pi over 18 is equal to, what's our first angle that has a sine of 1? Well, that's pi halves. Okay. So now, if I do this math, first thing it's asking me to do is to subtract pi over 18. So if I do that, this is 9 pi over 18, so that's going to be 8 pi over 18, which if I simplify would be 4 pi over 9. And then if I divide that by 3, I'm going to get 4 pi over 27. That is one of my solutions. How terrible is that? All right, now we got to do it again because 4 pi over 27 is not very big. So 3 theta plus pi over 18 is equal to, now the only one on the unit circle, the only angle that has a sine of 1 is just pi halves. So now I have to make it pi halves plus 2 pi. I have to go around again. So 3 theta plus pi over 18 would be equal to, so this is 4 pi over 2. That would give me 5 pi over 2. I'd have to subtract pi over 18, which would give me 3 pi, or 3 theta, is equal to, so let's see, if I multiply here top and bottom by 9, that's going to be 45, so that's going to be 44 pi over 18, which if I divide by 2 is going to give me 22 pi over 9. And then if I divide that by 3, I'm going to get 22 pi over 27. All right, but again, that is not even pi. So now what you have to do, and I'm not going to actually do it, I'm going to leave it to you, but I'm going to give you the final answer, is you would have to take this angle and add 2 pi again. So you're going around, you're at pi halves. We had to go around once to get 5 pi over 2, and you're going to have to go around again by adding 2 pi. So the other answer you're going to get is 40 pi over 27. And that's going to be all the answers that are going to work. Now, do you think there's going to be anything that difficult on any quiz I give you? No, but you should know how to do it. All right, let's look at number 3. If I want to solve this with the cosecant thing going on there, so that's a problem. So what I would do is I would change this to sine theta equals negative 1/3. So you just reciprocal both sides, basically. Now, since this isn't one of our special angles, we're going to have to use our calculator. And it would be inverse sine. What angle has a sine of negative 1 divided by 3? Okay, now here we go again. That is not between 0 and 2 pi. So the first thing I'm going to do to that is add 2 pi. And I'm going to get that answer right there. So theta is going to be equal to 5.94. That's one of my answers. So think about it again, just like we did before. Sine is negative in what 2 quadrants? In those 2 quadrants. So this is actually the 4th quadrant angle. So now, just like we did before, if I kind of draw a picture over here, So my fourth quadrant angle was negative 0.3398. I now need my third quadrant angle, which is going to be this angle right here. And remember, this is 0.3398. So I would have to take pi and add 0.3398 to get my second angle, which is going to be in that third quadrant, which is 3.48. All right, a couple of other things here. So it says to solve this one for all x from 0 to 2 pi. So the first thing we can see we can do is we can distribute. The second thing we should notice is, hey, wait a minute, I've got both a sine and a cosine. That's a problem. Remember our Pythagorean identities? Remember the one that said sine squared theta plus cosine squared theta is equal to 1? If I solve that for cosine squared theta, I get 1 minus sine squared theta. So that's what I'm going to do, is I'm going to solve that, and I'm going to take this, and I'm going to substitute it in there, because that's going to make everything in terms of sine. So 4 plus 4 sine theta equals 1 minus sine squared theta. Because of the quadratic, I'm going to bring everything over to this side. So when I do that, I'm going to get sine squared theta plus 4 sine theta. If I subtract 1, it'll be plus 3. Looks like I got a factor. Sine theta plus 3 plus 1. So if I take each of my factors and set them equal to 0, sine theta equals negative 1, and sine theta equals negative 3. Now remember, this is out of the zone, so sine can't be any smaller than negative 1, so we don't have to worry about that. For this one right here, there's only one angle that has a sine of negative 1, and it is 3 pi over 2. So there's only one solution to that one. We're going to skip down and do number 6 before we do number 5 in the grapher, just really quickly. So again, for number 6, you've got an issue because you have both cosine and secant. Let's change secant into cosine. So 2 cosine x minus, now secant is 1 over cosine, so this just becomes 3 over cosine x equals negative 1. Let's multiply everything through by cosine x to get rid of the fraction. That's going to give me 2 cosine squared x minus 3 equals negative cosine x. I've got a quadratic, so let's set it equal to 0. It does factor. Thank goodness, because I don't want to have to use my quadratic formula again. So 2 cosine x, 1 cosine x, a 3 here and a 1 here, and since I need a positive in there, this is going to be a plus and this is going to be a minus. So if I take this factor and set it equal to 0, I'd subtract 3 and divide by 2. That's going to give me cosine x equals negative 3 halves. Well, that's smaller than negative 1, so it doesn't do me any good. This one, cosine x equals 1. So what is the one angle that has a cosine of 1? It is 0. Okay, and then just really quickly for number 5, look, it says solve using your grapher. Woohoo! So remember, we've done solving equations in our grapher before. What you're going to do is you're going to go to your y equals. Now I've got an issue here. Notice how my plot, because I had a scatter plot in there earlier, so I got to get rid of that. So what you're going to do is you are going to go ahead and plug in the left-hand side for y1. So that's going to be x squared plus 3 sine x. And then you're going to plug in 0 for that guy. Now I'm going to graph, but of course, as you can see, we have a small problem. I'm going to zoom 6 to get, oops, I'm going to do zoom 6 to get back to my standard viewing window. So look, there's my graph. It's an interesting looking graph. Since the second equation is y equals 0, that's just the x-axis. So I'm looking for the two places where it crosses the x-axis. So that would be second trace, and I'm going to find a 0. Well, if you look right there, isn't it crossing at 0, 0? So one of my solutions is x equals 0. I can take that one. So now let's go ahead and let's do this one. So left bound, we've done this before. Right bound, and you can see that that is going to be negative 1.7. So there are your two solutions, and that is the end of the notes for 7.3.